Hello. Everything should be okay now. Do you hear me? Do you see the desktop? Is everything fine? Is it
Yes.
working? Okay, great. Thanks. All right. Um, okay. We're going to keep talking about higher order functions today. Now, I put up another reading assignment. Chapter 10 in the book is interesting. We'll say a little bit about it, but it's kind of a little bit off on a tangent. There's not much about ML in chapter 10. There's a little bit about it in there. It's about this idea of scope. Okay, so we'll say a little bit about it probably next week, but there's one more chapter about ML in the book. That's chapter 11. And that's way more important. So we'll do a little bit with chapter 10, and then we'll spend the rest of the semester talking about chapter 11, which is how you define data structures in ML. That's going to be something really important. So this is about what's scope of variables. And there's a little bit of about ML in here. See, there's an example in ML, and there's another example in ML, and a little bit about scope with blocks, okay, about ML. But then there's also quite a bit in here about Java and C++, about namespaces. That's see, about namespaces and things like that. So it goes off into other languages besides ML. And it's trying to talk about the idea of scope in a variety of different languages. And it's interesting, but we're right now I think we want to spend more time just mostly talking about ML. So we'll say a little bit about what's in that chapter, especially how it relates to ML, and then we'll go on to chapter 11. Okay, but first we have to finish higher order functions. Okay, so uh, we started looking at these examples in class the other day. Oh, and there's gonna this homework assignment is not quite there yet. I hope it'll be up there tonight. Okay, so I put it here to remind you that there's going to be another a program assignment, but it's not quite ready. Okay, so it'll be due then, but and hopefully it'll be up there this evening on higher order functions. Okay, so uh, there'll be a homework assignment. There's a reading assignment. It's a short. Oh, it's also a short chapter. It's not a very long chapter. An interesting reading assignment. It's something that's important. You should, the information in chapter 10 is useful if you're working with C++ and Java. But so we'll say a little bit about it, particularly how it relates to ML. But really, what we want to do is get to data structures in ML, chapter 11. Okay. Now, uh, we started looking at these examples in class yesterday on Tuesday. So I'm going to download this. I'm going to download this, and we're going to do some more of these examples. Remember, I give you a signature, and you have to give me a function that has that signature, a function that has that type. These are challenging little problems, and they're going to help us think about higher order functions. So I'm going to save that. And we did one of them, the very first one in class on Tuesday. So now we'll do some of the more challenging ones. Okay. So here's just open it in my editor. Okay. We did this one on Tuesday. So we'll go on to this one. Okay. So I want a function that does that. Now, remember how to read this. The arrows separate the inputs, and the last arrow after it is the output. So this is a function that returns a real number. And it takes in two inputs because there's an arrow here and an arrow here. It takes in an int and it takes in, now this is grouped by parentheses. So the parameter to this function is a function. So it's a higher order function. Okay, so we saw something similar over here. Here, this function takes in an int and gives us back an int. So it's a function from int to int, okay? And we give it an int, and we're given a function from int to int, and we're given an int, and we want to produce a real, okay? All right, so, and we should at least now we could do the following kind of dumb thing. Ignore this input, okay? And there's going to be an input, which is a function h, and a number n, and we have to give out a real. Well, if you give me an int and I want a real, I can just convert the number to a real. So remember, we have a function real that takes in ints and converts them to real. Okay, so I could do that. I'm kind of ignoring this parameter here. I gave it a name, but I ignored it. Now let's just check that that does what I wanted. Okay, so go here and open ML. Okay, right. Notice I have a function. Okay, now here's the thing. Since I ignored that parameter, ML doesn't know what to do with it. So I didn't really get the answer I wanted. Unlike Java, since ML is doing the typing, if I ignore the parameter, ML just says, oh, it's a type A. See, it didn't make it a function from int to int because I didn't use it. Okay, so ML didn't really say that this function does what I want it to do. Okay, so let me go back. Now let me use this function. Okay, well, here's an int. This function takes in an int. So why don't I just apply the function to the int and get back another int and then take the real of that. Okay, so take this function from int to int, plug this int into it. I get out an int, and then I take the real of it. Okay, so try this one now. Okay, and now I get well, I almost get the answer I want. Okay. Okay. ML has no way of knowing from what I wrote here that this is really an integer. See, if ML typed it as type A to int A and a real. So it said it thinks it got a function in that goes from any type A to int, something of type A, and it gave me out a real. But I wanted the answer to be int to int. So I could do something like this. Just add, we did something like this the other day. Just add 1 to n. If you're going to add 1 to n, it must be an int. So that forces ML to think of this guy as an int now. So now ML is going to think of this as an int, but then this has to be a function from int to int. Okay, so now go over here and try it again. Oops. Okay, and now I get the type I want. Okay, int to a function. The function takes in a function from int to int, an int, and it gives me back a real. Okay, so there's a solution to the problem. This thing actually takes in a function that is from int to int, and it takes in an int. ML knows that's an int because I added 1 to it. Well, if that is an int now, then the input to this is an int. But the output of this has to go into real, so the output of this has to be an int. So h has to be from int to int. There's the int, and it gives me out real because that function returns a real. All right. So I figured out a way to match that type with where it's an example of a higher order function. Okay, let's go to the next one. Okay. Similar, I want a function that takes an int. I want there to be an input function, so I'll call it h, and a real number. I'll use x for the real number. And I want to give out a real number. Well, I could just give out x. X is a real number. I want out a real number. The trouble is, since I'm ignoring h, ML is not going to think of it as a function from int to int. Okay, so I shouldn't ignore the h. Okay, okay. Now, I can't plug this number into, well, if I plug that number into h, ML is going to say that now that this is a function that takes in a real. Okay, see, that's a real number. We think so ML is going to think of this as a function that takes in a real number. Okay, well, I want it to be a function from integer to integer, but the input being a real. So if this is a real number, why don't I round it to an int? Okay, if I take in that real, so there's my real number, I can round it to an int. Okay, now it's an int. Now I can feed it into h. Okay, h is supposed to be a function from int to int. Okay, all right. but I want the output to be a real. So H right now takes in a real, but ML doesn't really know what it's supposed to produce. I want it to produce a real number. Okay, so let me take the real of H of round X. Okay, now let's read this from inside out. X is some input to round. Round takes real numbers and turns them into ints. So X must be a real number. That's what we want. We want X to be a real number. Now round takes it, converts it from an int, a real to an int. So now the int goes into H. Okay, so there's an int going into H. That's what we wanted. Now what comes out of H? What comes out of H goes into real. Well, what goes into real is an integer. So that means the output of H has to be an int. So we got that. What's the output of real? A real. Okay, so this should be what we want. Okay, notice that we kind of work our way from inside out and just kind of piece it together piecewise. We have some function, so we'll call it H. We have some number, call it X. Then try to piece things together so that the input is a real, the function's from int to int, and the output is a real. Now let's check that this one gives us the type we want. Okay. Function from int to int, a real, and it gives out a real. A function from int to int, a real number, and gives us out real. Okay. All right. All right. So notice it's one of the parameters to our function is a function. Okay, so I'm using a generic name like H to represent a function. And then we just have to think of how to use it to get so that the other input to this function is a real and the output is a real. Okay, all right, now let's play with one that involves lists. Okay, here's a function that takes in, okay, it's only got one arrow here because this is a grouped thing. So the function takes in something and gives us back something. What it takes in is a function. So F4 takes in only one thing, a H, a function. And then it gives us out something. Okay, so it's a function of one input with one output. Now the input is a function. The function is from a list of A's to a B item. And we want to get a B item here. So if we give H some input, it'll give us out a B. But what input should we give H? See, we don't have anything else to play with. The function only takes in H. H is a function from a list of A's to a B. Okay. If we give H something, it'll give us this B we want. But the question is, what can we give it? How can I cook up a list of A's? Here's a little bit of a trick. Can you anybody think of a list of A's where I don't have a clue what the A's are? What can I make the 3 question marks? What's an example of a list of A's where I don't know what type A is? So I can't make it a list of int. I can't make it a list of string. Okay. Okay. What list can I make it? So it's a list, and it's a list of A's, but I don't know what A is. Anybody have a guess?
Would you just use X double colon XS or no?
Well, the trouble is, let's see if we can do that. Well, first of all, I haven't declared them. See, what's wrong with, see, I can't say, see, you're using that on the right-hand side of the equal sign. That variable's never been declared because it's not on the left-hand side of the equal sign. So I can't write that. That's a pattern that would go on the left-hand side of the equal sign to say that this is an input. So something like that, if I moved it over here, but now I'm saying the function has a second input, but this function only has one input. So I don't have X and X's. See, that's the problem. I don't have them. Okay. So because I can't put it on the right-hand side, I can't put an X on the right-hand side because I didn't declare it on the left-hand side. And if I put it on the left-hand side, I'm declaring a new parameter. So the puzzle is, how do I give H an input when I don't have any other parameters over here? This has got to be a list of A's. It's got to be an A list, a list of A's, but I don't know what A is. Can't be a variable. If it can't be something that's if something's not a variable, then what is it? In a programming language, if something's not a variable, it has to be something else. If I write something on the right-hand side of an equal sign,
It will be a function.
well, a function is a variable. See, it's got a name. Now over here, I cannot use a name because I have no other names involved on the left-hand side. I'm defining the name F4, and I'm defining the name H. F4 is the name of the function, H is the name of the one input parameter. In a programming language, if I have something that's not a variable, what can I write there? How can I write something on the right-hand side of an equal sign that's not a variable?
Is it a constant?
A constant, yeah. Well, a better word is literal. Or, okay. For example, there's a integer literal or integer constant. There is a double literal or double constant. There is a string. Notice I'm not writing any variables yet. There's an array literal. So there is an integer literal, a double literal, a string literal, an array literal, no variables. Okay? So if you can't write something that's a variable, you write a literal, a constant. Okay? So over here, I can't put a variable there because the only variables I have are F4 and H. F4 is the name of the function I'm defining. H is this input parameter. So I have to put a literal there. It's got to be a list, but I don't know what goes in the list. What literal can I write that's a list where I don't know what I can put in the list?
An underscore?
Nope, because underscore has to bind to something. It's essentially, underscore is a variable with no name. So it's still a variable. It's a variable that you're not going to use. So you use underscore. Okay. So underscore has to be on the left-hand side of an equal sign. It's essentially a variable that you don't care what its name is. So it's not a literal. See, underscore is not one of these literals. It's not a constant. What else do I? Okay, so I need a literal list of A's where I don't know what A is.
Do you have to use brackets?
Well, lists are brackets.
I'm not sure if that would go on the left side only or if that works on the right side too.
Well, what do you mean by brackets? I mean, here's a pair of brackets.
Well,
Would
so
an empty list work?
the other way around.
Why would I put, well, then what is that? But see, if I put them the other way around, I'm writing
That's
something
an
very specific.
an empty list, but
Empty list. Yeah, is that a literal?
yes,
Yes. Is it a variable?
no, because
It's a
say,
literal. Yeah.
list.
Is it a list of A's?
No,
Why not?
because it has to be an empty list.
It is the empty list. Is it a list of A's?
No.
It worked. It is a list of A's. Because ML's polymorphic. The empty list is both, come over, think over here. Here's how I write a list of integers. Here's how I'd write a list of strings. Here's how I'd write a list of doubles. Okay, now, here's how I write it. How do I write an empty list of integers? What do I write? I wrote a list of integers that's not empty. How do I write empty list of integers? It's not rocket science. How would I write empty list?
Just the 2 brackets.
Yes. Now, how do I write empty list of strings?
Same.
Same. How do I write empty list of doubles?
Same.
Same. ML's polymorphic. Okay. ML's polymorphic. The empty list is polymorphic. It can be the empty list of strings in some situations, the empty list of integers in other situations, the empty list of doubles. Okay. Because 1, 2, 3 is by definition the following. It is by definition 1 constant to 2 constant to 3 constant to the empty list of integers. Cat dog is by definition the literal cat constant to the literal dog constant to the empty list of, but what's this guy? The empty list of what?
Strings.
Strings. Okay. But this guy is the empty list of?
I would say whatever the preceding one is.
Yeah, that's the more general answer, whatever the preceding one is. Because if you're going to take a 3 and add it to the empty list, it's got to be an empty list of integers. If you're going to take dog and add it to the empty list, it's got to be the empty list of strings. And then in this one is 1.2 constant to 3.4 constant to the empty list of reals. Okay, so notice that here, this guy is the empty list of integers. Here he's the empty list of strings. Here he's the empty list of reals. Okay, if you write this guy all by himself, he's the empty list of A's. Because ML's polymorphic, so ML's not sure yet what kind of empty list it is. So written by itself like that, it's the empty list of A's. So this would be the type A list. Because I haven't put anything in it, so ML doesn't know what will go in it. So over here, see, it's the empty list of A's. Because I didn't tell ML otherwise. Now I can do this. I can say, oh, I want him to be an int list. So now I've told ML that that's the empty list of ints. Because notice the difference. If I just type that, ML types it for me. It doesn't know anything else about the empty list, so it says it's an empty list of A's. If I do that, but I say it's a real list, then ML says, yeah, it's the empty list of reals, because you told me it's you told me it's a real list, so it's the empty list of reals. But if you just write the empty brackets by themselves, it becomes the empty list of A's. Okay. In this example here, okay, we're supposed to take a list of A's. We have a function from list of A's to something that's a B, and we're supposed to cook up a B. So just give that function the empty list. And by definition, this function takes in any list of A's, in particular the empty list, and it produces a B item. Okay, so that function, as we saw, that function has the type we want. Okay. ML says F4 takes in a function from A list to type B. I gave it in particular the empty A list, applied it H to it, and I got it back out of B. Okay. So ML, yeah, it's kind of a weird example because I don't know what type A is and I don't know what type B is, but F4 is a function that will produce a B item out of a function from A list to B list. Okay. Right. Okay. Now let's try another one. Okay.
I have a question.
Yeah.
And you may have already explained this, but can you explain like how do you read the parentheses in that output? If that makes sense, like
Well, okay, that output was this type. I mean, this type here.
Right, like the parentheses around that first part of it.
Okay, this is a function type. Functions take inputs and outputs, right? If you go back, if you think of it in terms of Java, you're used to this kind of stuff. Double F of int x, double y, string z, right? The function takes in inputs, x, y, and z. They have types, and the function returns something, right? That's how you write a signature in Java or in C or C++. Okay. In ML, signatures are written with these arrows. The last arrow, after it comes the return type. Okay, so in this example I just did up here, if I was writing this in ML, double would be there. That's the return type. Then between the arrows are the input parameters. So for example, this one has an int input. Oh. This example here has a int input. Then it's got a double input. Okay. Then it's got a string input. Okay. Here's the ML way to write that type there. A function that takes in int, double, string, and returns double. Takes in int, double, string, and returns double. So the arrows, so this is, param 1, param 2, param 3, return type. Okay, so that's the beginning. So you separate the parameters from each other by arrows. Okay, now what if one of the parameters is itself a function? Okay, so I have input, 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 return type. What if this input is a function? Well, how do you describe a function? With these arrow signatures. So suppose this guy is a function that takes in an int and gives me out an int. You see a problem here. This is a parameter to my function, but it's a function parameter. It takes in an int and gives me an int. But the way I wrote it doesn't, what's wrong?
Yeah, the order is going to be messed up.
What do you mean by that?
You need to process that function and then use the result as the parameter type.
No, I'm not processing the function. I'm not calling it. I'm declaring it. I'm telling you what the input types are. See here, if I make this a function, in Java, you can't really do this, but if this is a function, I have to tell you what its type is here. I'm not calling it here. I tell you what its type is. Where do I call the function? Oh, I should use a different letter here. H. Where do I call the function? If I'm declaring a function f that takes an input x, an input h, and an input z, where do I call this function?
Inside of f?
Yeah, inside, yeah, it'd be in here in the definition of f somewhere. Somewhere in here would be a h of, say, h of 5. Okay, so here I'm declaring it. I'm calling it in here. So here, there's the declaration of the function, not the calling of it. Okay, so I have some parameter 1, the type of it, then a parameter 2, the type of it, then I have this function parameter, and then I have the return type. But what's wrong with the way it's written?
It's written like there's 4 parameters.
Yes, it's not written like there's 3 parameters. It's written like parameter 1, parameter 2, parameter 3, parameter 4, then the return type. So how do I make that have 3 parameters, not 4?
The 2 ints are grouped.
Pardon me?
You group the
Yeah.
int to the int.
Yes, see, that's where those parentheses were there for. Group, now it's saying 3 parameters. Parameter 1, parameter 2, parameter 3. But
So parameter 3 is just a function then, right?
Yeah, parameter 3 is a function now. So I need the parentheses to group around this arrow so that without the parentheses, ML would read it as 2 parameters, not 1 parameter. This would be parameter 1, parameter 2, parameter 3, parameter 4, then the return type. But I want parameter 1, parameter 2, parameter 3 is a function. So I have to group them. Okay, so for example, this could be int, string. Parameter 1 is an int. Parameter 2 is a string. Parameter 3 is a function from int to int. And the return type could be, say, a string. See, there's a function from int, string, function from int to int, 3 inputs, and that output. Okay, so now, for example, suppose I wanted this one to be a function from string to int. But right now it looks like parameter, 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 parameter. If I want this to be a function parameter, I have to group it. Okay, now the function I'm declaring has an integer parameter, a function parameter that's from string to int, a function parameter that's from int to int, and it returns a string. And with a little bit of effort, I could probably make a function that does that. Well, we can even give it a try in a minute. But see, that is a signature. That's a function type. The word signature is often used as a synonym for function type. Okay, these are called signatures in Java. Okay, so like if you see a function signature, type signature, method signature. Yeah, see, this is from this is actually something out of the JavaScript. This is a see what they're doing here is they're saying this is the JavaScript documentation, but they're helpfully trying to define words that are not just purely JavaScript word. The word signature applies to every programming language. A signature is something that a function has. It's the function's type. How do you tell me how many inputs the function has, what type they are, and what kind of thing a function returns? The signature tells you how many inputs there are, what type each input is, and what the return type of the function is. Okay. In Java and C and C++, they all use the same syntax for signatures. Looks like that. Return type, name of function, parentheses, comma separated list of type variable name, comma separated list of type variable name. That's a signature, okay? And then after the signature is the function body, the actual method, what the function does. What the function does comes after the signature, okay? In ML, you don't type signatures. ML figures them out for you. What we're doing over here is I want that signature. Notice that's a comment because that's something that I want ML to tell me. I give it the function definition and it tells me what the signature is. In ML, you don't, I mean, I can write the signature if I want, but usually we don't. We write the function definition and let ML figure out the signature for us because it does type inference. So this is something, I couldn't do homework exercises like this in Java. I can't give you a function signature without giving you the function declaration. In Java, the signature and the declaration are one and the same thing. In ML, I can write a function's definition, and then ML gives me back the function signature, what its type is, okay? And then, and then the grouping says, well, okay, here, that arrow separates one parameter from the next parameter. That arrow, since it's the last one, separates a parameter from the return type. And since on the left of this, what's grouped, see, without that grouping, okay, without the grouping, you read that completely differently. Now it's a function that takes in 1, 2, 3 parameters. It takes in an A thingy, a B thingy, and an A thingy, and it gives me back a B. Okay, so it takes in 3 parameters and gives me back one thing. Okay, the way it was, it takes in 2 parameters, a function from A's to B's, and an A, and it's supposed to give me back a B. Okay, so it's like on this one. The first parameter is a function from A's to B's, so I'll just call it H. Then I get an A thing. I'll just call it X. Now I'm going to say what to do with the function and the A thing. I'm supposed to produce a B thing. Well, I've got an A thing and I've got a function from A's to B's. So the obvious thing to do is apply the function to the B thing. Now notice how weird that is. This HX on the left, it has a completely different meaning than this HX on the right. All right, tell me, what does that mean?
H and X are both parameters?
Yes, it's declaring the input parameters. It's saying that there's an input parameter called H and another input parameter called X. What does this mean? When you write 2 names next to each other in ML, that has a very specific meaning. In ML, if I write A, B, what does that mean? By now you should be pretty clear. What does that mean? If I write 2 letters next to each other, what does it mean?
It's a higher order function?
No, it's just
Curry?
no. Well,
Function.
a function. Call A with input B. This is how you call functions in ML. You write the name of the function followed by the parameter. So what in Java will be written like this, in ML is written like this. Remember, you can write this in ML, and all that does is it groups the 5 by itself. Okay, it groups the 5 by itself. It doesn't, so the parentheses don't mean anything. It's like if you wrote in Java, here's 3 plus 2, right? What do those parentheses mean? What's the difference between this and this? What's the difference between that and that? That would be an awfully, what does that mean? What is that?
Are they both the same?
Why?
Because the parentheses are not needed?
The parentheses are not needed. They're gratuitous grouping, but they just group the 3 with itself and group the 2 with itself. That's what ML does here. It's just gratuitous grouping. If this is Java, here that's function call. This is ML. That's a function call with a gratuitous parentheses. It's just like the parentheses here. They don't mean anything. You're grouping 3 with 3. For example, I can do the following. More gratuitous grouping. Yeah. And Java is perfectly happy with, if you want to write all those parentheses, Java will accept them. You could even do this. That's perfectly legitimate Java. The compiler will just throw away all those parentheses because they're not needed. You can have all the gratuitous parentheses you want. Now watch, in ML, I can do this. What about in Java? What if I do that?
I would guess it wouldn't compile.
Why not?
Syntax errors from
Yeah, it's a syntax error. If you call a function, you only have one pair of parentheses. It's not grouping. It's very different. This is grouping, and gratuitous grouping is always okay. You can gratuitously group all you want in any programming language. You can put all the parentheses, just like down here, I can put all the parentheses I want around that 3. That's perfectly okay in Java. That's not perfectly okay in Java, because now I'm doing a function call. That's a function call, and a function call can only have one pair. Well, actually, Java probably will accept this because it'll group it this way. Actually, I think it might actually group it like that. So what will it do? If I write it like that, how did Java group it?
Are you saying the spaces matter?
No, they don't, but they help me think. They don't matter, but I think this will be, we'll try it in a second. I'll open the Java visualizer and but think of it. Here's what I'm thinking. I think Java will accept this, but I think Java is going to think like this. What does that mean? The spaces aren't significant, but they're supposed to help you think.
It's declaring a function with just the parameter of 5.
And what about those? What about these?
They're dropped.
They're gratuitous grouping. So they're dropped just like all these are dropped, and all these are dropped because 3 plus 2 is 3 plus 2. So I think Java will treat those 2 as gratuitous grouping. ML would treat all of those as gratuitous grouping. Okay, so I can go over here at ML. I'll say fun f of x is x plus 1. Okay, so there's a simple little function that just adds 1. Okay, f of 5 gives me 6. F of 5 gives me 6. F of see, but that's all gratuitous grouping. Okay, that's just all gratuitous grouping. The grouping just didn't mean anything. Okay, now let's try it in Java. I'm going to have to type a little bit more code to get this to work in Java. Say public static int f of int x is return x plus 1, semicolon. Okay. Notice I have to type a lot. I have to type a lot more in Java, but there's a function. Then over here, I'll say int y equals f of 5. Okay. So visualize it. Oh, darn it. The visualizer's stuck. Okay. Let's see if it. Exceeded max visualization time limit. Maybe they're really overloaded, but okay. Their server might be really under stress right now. I didn't type something stupid, did I? Int y equals f of 5, int f. No, yeah. So let me save this, just close that and try over again. See if I get better luck by going back to the website. Well, okay. So see, y is 6. Okay. Now, what happens if I put is I'm pretty sure now that Java will accept this, but it's just going to treat 3 of those parentheses as gratuitous, and one of them is meaning function call. See? Okay. So notice that, but there's a subtle difference. That first parenthesis means function call. Then the other parentheses mean grouping. These mean grouping. This means function call. In ML, there is no parentheses in a function call. So in ML, all of those parentheses are grouping. Because in ML, when you make a function call, you're really supposed to just write the name of the function and then the parameter. Okay, so you're supposed to just write, you don't need any parentheses. Okay, now go back to what we were working on over here. See, I had this funny thing. What I wrote on the left side and what I wrote on the right-hand side look the same, but they have completely different meaning. In the left-hand side, I'm declaring 2 parameters, one called h and one called x. On the right-hand side, I'm saying, oh, call function h with input x. Okay, and it's just a coincidence that they have kind of the same notation. Now, here, h is a function from a's to b's. X is an A, so when I feed X to H, I'll get out a B. Then I can check this over in ML. Okay, so it's got the signature I wanted. Let me do a modified version of this example. So here's example 5 prime. Okay, it's going to take in A and a function from A to B and give me out a B. So the function takes in an A and a function from A to B, and it gives me out a B. What do I change down here to get the prime version? How do I change the formula now? How do I change line 66?
do you group X with another H?
I'm not sure what you mean.
Neither.
Can you just con the X on the left side to X's and then you can keep the right side the same?
Okay, I'm gonna keep the right side the same because I want to apply H to X. What do I do on the left side?
Just add the X's after X.
What X's?
I mean, so put a semicolon and then X's. Or not a colon after X. 2 colons, I mean, sorry. And then X's.
Nope, that doesn't mean, nope. That says I have a list. I don't have a, no, my signature says nothing about lists.
Oh, sorry, I was reading the wrong one.
Yeah, my signature has no list in it.
So on the left-hand side, I was thinking H, and then in parentheses, H and X.
No. Okay, let's read it real carefully. The function needs what? The function takes in what?
Takes in the A,
An A thingy and
another function.
then a function. And it's supposed to produce a B.
So can you just switch the order of X and H on the left side?
Yes.
Okay.
See now, X is the input, H is the function. And then on the right-hand side, I call the function with the input. See here, by coincidence, I had written it where function and its input. So there's the function and its input. Then when I call the function with its input, I write the same thing. Here, I wrote the, here's just a different order. The input and the function. So there's the input and the function, and then call the function with that input on the right-hand side. Okay, so this one's just kind of a coincidence that it got written the same thing on the left and right-hand side. Programming is all about these details. You're not going to write thousands lines of JavaScript code for a company if you can't figure out what all these symbols on the page mean. I'll show you plenty of JavaScript code that's way more complicated than this is. Once you start getting into real code that real companies write to make real money for real jobs, this is not complicated. I'll show you lots of JavaScript code, lots of Java code that's way more complicated than this. Okay, but you have to read you have to know what every little symbol on the page is doing. You don't skim code. It's not English. You read every single letter and you have to know exactly what every single letter is doing. So you have to know exactly what this guy is and exactly what this guy is. And that's not the same thing as this guy here and this guy here. This is a declaration. This is a function call. This is two declarations and one function call. Here, two declarations in the other order, one function call. Okay, parsing and analyzing that many letters is really important. Because if you want, I'll show you way more complicated code than this written in JavaScript or Java or heaven forbid C++. Where parsing one line of code can take me 15 minutes. I mean, I've seen plenty of C++ code where it takes me 15 minutes to read one line of code. I mean, I don't like working with C++ anymore because the language is becoming really hard to work with. But it's not hard to write one line of C++. If you're not an expert and you don't work with it all the time, one line of C++ can take a long time to read. And the way you read it is you break the line up into every little piece you can. What is that guy? What is that guy? What is that guy doing in the syntax? Well, that declares a function. That would be the name of the function. Oh, what comes after the name are parameters. So these are parameters to the function. This separates the declaration of the parameters from the body of the function. Okay. In ML, if I write two letters next to each other with a space between them, it means function call. I'm calling H with parameter X, and the semicolon just ends the definition. So I have to figure out what all those little pieces mean. And I'm trying to match that. I'm trying to match that type signature. So again, I have to figure out what everything means here. That means it's the type of a function. The type is, well, parameter followed by parameter followed by return value. Yeah. So the parameter is a function because it's got this grouping around it. So the parameter to this function is another function that takes in an A thing and it gives me out a B thing. Then this function takes in an A thing, and then this function gives me back a B thing. And that's what I wanted to do. And that's what this one here does. Okay. Then this one here can check. This one is going to have this signature here slightly different. Okay. Function from A to a function that takes in an A, and a function from A to B and gives me out a B. See, the function took in an A thing, that's the X, an A to B function, that's the H, and gave me out a B. By plugging the X into H, I got out a B from H, because H gives me B's. H gives me B's. Okay? I'm trying to force you to think really hard about one line of code, because when you get into the real world, you're going to be doing this. You know, you don't write 100 lines of code a day well, there are jobs where you write 100 lines of code a day and you don't think much about any of them because it's all boilerplate. Those jobs will end up being replaced by AIs in the near future. If you can write 100 lines of code a day without thinking much, your job's going to be replaced by an AI. The jobs that are going to remain 10 years from now are the jobs where you have to write lines of code that are complicated, where you have to read them carefully and actually pull apart the meaning of the code. So one line of code, you have to pull it apart and figure it out. If the code is so trivial that you don't have to give it much thought, believe me, it'll be written by AIs. In a couple more years, it's already starting to happen. The AIs are writing the simple boilerplate code. Okay, what were like the low-level programming jobs, that stuff can just be automated. You know, the code can be spit out by there's these code, they're called code generators. You know, so the code is just produced by a code generator, and it can produce lots of boilerplate code that's pretty straightforward. Then the hard stuff is the stuff where you have to really figure out the meaning of it. Okay, so these are practice problems in pulling apart the meaning of one line of code and making sense of it, forcing yourself to ask, what does every symbol in that line represent? Okay, and we've given you, you have the meaning. The hard part now is to put it together. We know what the star means. That's a tuple. Like in this case here, star means tuple. Okay, what I've got here is a tuple of two things. Okay, so here there's only one arrow. So this is a function that takes in one parameter and gives me back a B. But that parameter is a tuple of two things. It's a tuple of a list of A's and a function from A to B. Okay, now actually 6 is actually 5 over again. 6 is 5 where this has been turned into a star. So I've tupled the two input parameters instead of curried the two input parameters. Again, forcing you to think real hard about the simple, like that star versus that arrow. 5 is a curried function of two parameters. 6 is a tupled function of a pair of inputs. Okay, so 6 is real easy. 6 looks like this. H comma X. See, instead of the inputs being curried, the inputs are tupled. Then I do the exact same thing with them. 6 is 5 with the inputs tupled instead of curried. A function from A to B, an A thingy, and then I want a B thingy as the output. But these guys come in a pair. So they came in a pair. Then I take the first thing in the pair, that's the function. The second thing in the pair is the input. Okay, check this one in ML. Whoops, it didn't. See, the function takes in a pair. That's what the star there means. That's a pair. The left side of the pair is a function. The right side of the pair is an A. Okay, that's the H and the X. Then it's supposed to give me a B, but the function's from A to B's. So if I apply the function to the X, I'll get out a B. Okay. So 6 and 5 are only different in the fact that 5 was curried inputs. 6 is tupled. I'm sorry. 6 is the same inputs tupled instead of curried. Okay. And if we wanted to, we could do a 6 prime. 6 prime would put the list of A's at the front of the tuple instead of at the end of the tuple. Okay. And then that would make the X at the front of the tuple instead of the second of the tuple. Okay. And then this would be 6 prime. Okay. Okay. So A is the first thing in the tuple. The function is the second thing in the tuple. So X and A, now it's XH. And then the output is H of X still. So it's always the same output here. I'm going to apply the function to the input item. What's the, oh, wait, no, I'm sorry. There's no list in here. I don't know. Oh, let's see. Oh, I'm sorry. I was skipping over this a little bit too much. A5 was an A. This is an A list. Okay. I actually meant it to be just an A. I think I had a type. I meant it just here. This is the tupled version of this. So this was just an A, not an A list. Okay. I wasn't paying attention real carefully. So that's supposed to be just an A. Okay. So 5 was this one. I don't know why I had the word. I think it was just a misprint in my case. I had to go make sure I remember to fix that. That was supposed to be just, so this one here is just an A. Okay. So 6 is the curried version of 5. Okay. Instead of it's the tupled version of 5. 5 is curried. 6 is tupled. Okay. 5A is curried. 6A is tupled. Okay. All right. Now, actually, if you go back and make that 6 double prime, we could do that. Let's go back and the way I had it. I had write that as, say, 6 double prime. I had a list here. That changes it. So it's, that changes it a little bit. Okay. Now I've got a pair. This is a function from A's to B's. This is a list of A's. So this is a list of A's. And now I need to produce a B. So now I can't, now H doesn't take in X, H takes in, see, the function is from A's to B's, but this is a list of A's. Okay, so here's where I need the cons operator. I'll do this. And I'll say, okay, function from A's to B's, a list of A's. I'll break it up into its first item and the rest. Then I'll apply the function to the first item. In fact, here I don't even need those, so I'll just do that. And this is 6 double prime. Okay. Okay, so now I've got a function from A's to B's, a list of A's. I can't give the list of A's to the function because the function doesn't take a list of A's, it takes only a single A. But if I've got a list of A's, I can take the first one of them and give it to the function. Okay, so now this one will have list of A here instead of just A. Whoops. Oh, but then I get a warning. Now, that's okay with me. It's a warning. Does anybody see what the warning is about? What is true about this function? 6 double prime.
It doesn't know what to do if the has an empty
Since I need an A item to feed this function, I can't really define this thing on an empty list. See, my idea is that I have a function from A's to B's and a list of A's, and I need to feed one of the A's into the function. You can't give me an empty list because then I don't have an A to feed into the function. So I'm stuck with my function left with the case that it doesn't know what to do with the empty list. If I want to be real precise, I could say my function f6 double prime, if you give it me any h, I don't care what it is, and you give me the empty list, I don't know what to do with it. Does anyone remember what we do? What should we do in this case? We saw something like this before. I want to keep the compiler happy. So I'm going to tell the compiler what to do on the empty list. But I have no idea what to do on the empty list. What do I do here? What do you do in Java if you've got inputs that don't make sense? What do you do in Java if you've got a function and you know that what do you do to handle the case where the inputs don't make sense to the function? What's the technique in Java how do you define a function to deal with inputs that don't make sense?
You raise an exception.
You raise an exception. So, and we can do that in ML. So we throw an exception. In Java, you throw an exception. In ML, you raise an exception. I forgot even what the syntax is for it now. You just say raise, then the name of the exception. So what I'm going to do here, if I remember right, I say, let's see, do I put an equal sign? Yeah, I think I say equal raise empty. I think the name of the exception is empty. Okay. See, the idea is here, if you give me a non-empty list, I take the first thing in it and feed it to H. If you give me an empty list, I don't care what function you gave me. I have nothing to feed it. So I'm kind of in trouble. So I'm going to raise an exception. I'll raise the empty exception. Now, the compiler says I've covered all cases now. I've covered the non-empty list case and the empty list case. So the compiler won't complain. Now I got to get rid of that semicolon and put the semicolon on that case now. So go over here. Okay, see, compiler's happy. Same type. Fn is a function from A to B and an A list and gives me back a B. Okay. This one, I didn't tell the compiler what to do with an empty list. So it gave me a warning. Here I said, okay, on the empty list, I'm just going to throw an exception. I don't know what to do on the empty list, but at least the compiler knows that I've dealt with that case. So I've dealt with the empty list case now. I can't really do anything else. And that's perfectly okay. The tail function of an empty list throws an exception. The head of an empty list throws an exception. There are functions that don't know what to do with empty lists. There is no tail to an empty list. There is no first item in an empty list. So there are functions that have to throw exceptions. So now, see, I didn't catch the exception, so I have an uncaught thrown exception. Actually, it's weird that they use the word raise, because then they're using the word uncaught. Well, you don't raise something and then catch it. You throw something and then catch it. So Java, you throw exceptions and then you catch them. But in ML, you raise exceptions and then catch them. So it's a bit of a mixed metaphor. At least Java was consistent about the terminology. Throw exceptions and catch them. In ML, it's raise exceptions and catch them. Okay. And in C++, it's also throw and catch. And I think in JavaScript, it's also throw and catch. But there's several other languages that use the word raise. Raising exception is kind of a pretty common terminology also. So either throw, or some languages you throw exceptions and some languages you raise an exception. But I don't know if there's a companion word for raise. If you raise exceptions, what should you do when you didn't, what is an uncaught raised exception? I don't know what is, they just use the word caught. Okay. All right. So I could fix, I meant 6 to be the, I meant 6 to be the tupled version of 5, but I actually had I had an extra word in there, but that's still an interesting problem. Now it's a version of 5 that's both tupled, but it also takes in a list instead of just taking an item. Okay. Okay. Now let's try another one. Now I'll read this carefully. There is an input parameter that's a function. There's another input parameter, there's a function. There's a single parameter, it's not a function, and there's what the output is. Okay, so what F7, I'll need a function. So I'll call it H. Then I need another function. I'll just call it G. Then I need an item. I'll call it X. It's not a list or anything, so it's just an item. So X is a good name for it. Now, I need to produce a C object in the output. What can I do with the A thingy? Well, this first function takes in A's. So that leads me to think that I should apply the first function to the X. I should apply the first function to the A thingy. But I need a C thing out. But the second function gives me C things out and it takes B things in. Oh, but notice that the B is what this guy produces. So this produces a B. If I group this like this, H of X is a B. So that can be the input to G. Right? So now X is this A thing. X goes into the H, which takes in an A thing and gives me out a B thing. But I'm going to feed it into the G, which takes in a B thing, gives me out a C thing, and that's what I wanted here was a C thing. Okay, so there's the answer to that one. Real simple. Notice that the answer is shorter than the type. Okay, that's not so unusual. The type is more complicated than the function itself. I go over here and I'll check it. Whoops. My copy and paste key isn't working on the keyboard. Okay, so there's the type I wanted. Okay, a function that takes in a function from A to B, a function from B to C, an A thing, and it gives me out a C thing. Okay, that's what I wanted. Okay, one last one, because once you start getting the hang of these, they're not that hard. A function parameter, H. Function parameter, G. A thingy, X. Okay, there's my inputs, 1, 2, 3 inputs. I'm ready to say what to do with the output. I need a B thing out. Well, I got a C thing in. Well, the second function takes C things in. So apply G to X. Okay, well, okay, this function took a C thing in and it gave me out an A thing. But the A things go into the first function, which gives me out B things. So actually, this is a lot like the first. 8 is just like 7. It's just got the order of these functions reversed. Notice that here I did HGX, GH of X. Here it's HGX, H of G of X. So it just reversed the order of the functions. So there's 7 and 8 are almost the exact same problem. Okay, there was just a little, see, this took in an A and gave me out a B. This took in a B and gave me out a C. This took in an A and gave me out a B. This took in a C, gave me out an A. But if I think of it backwards, C in, A out, A out, A in, B out. So I go from C's to B's. C in, A out, A in, B out. I can go from C's to B's. Here it was A in, B out, B in, C out. So I'm going from A's to C's. I'm going from A's to C's. Here I'm going from C's to B's. C in, A out, A in, B out. I'm going from C to B. Okay. Once you get the hang of this, they can start going kind of quickly. So we'll pick up on, there's just more of these. We're building up to the functions that are actually useful. Okay, we haven't quite, most of these are exercises and forcing you to think, but we're actually building up to three important functions called filter, map, reduce. And if you Google filter, map, reduce, you're going to see JavaScript, Python, Java, huge numbers of web pages. Filter, map, reduce are really important higher order functions. You see them just, they're just talked about all over the place. So we're building up to the filter, map, reduce higher order functions. Okay, so let's see, I forget which one it is. Map is one of these down here. Okay, one of these is map. One of these is map, and one of them, So that's what we're building up. But we first got to get good at reading these things. We need to get good at understanding what these things are saying before we can start talking about filter, map, reduce. One of the reasons why you see so many pages describing this stuff, because a lot of people have trouble understanding it. So lots of people are trying to explain filter, map, and reduce to people because everyone's trying to learn filter, map, and reduce right now. So you see tons of articles. You can just step through page after page on filter, map, reduce, filter, map, reduce, filter, map, reduce. It's just going to be pages and pages and pages of people explain, and mostly it's about Python and JavaScript right now. Python and JavaScript and a little bit of Java. Some of these pages are Java. Most of these pages are JavaScript and Python because data processing, like in big data systems and machine learning, these are becoming the workhorse tools. They came out of ML. They originally came from ML, but they are now the tools that people use for doing data processing. And so if you look at these pages, you'll see that a lot of times they're talking about data processing pipelines like this. Filter, map, reduce, pipelines that process data. Okay. So we're building up to it by doing it really from scratch, really asking to understand these signatures, how they work, and then with a good foundation in this low level stuff, then we can explain what filter, map, reduce do. Over here, a lot of times people spend page after page explaining it because they're trying to explain it without doing the low level. It's real hard to explain this high level stuff if you don't understand what it's built on. It becomes a house of cards, a house built on sand. It helps to understand this low level stuff before you try to do the higher level stuff. Because otherwise you're just otherwise you end up with people who kind of know what it means, but don't really know what it means because they didn't sit down and figure out how to read these things. Okay, so we'll quit there. Okay, so on next week, we'll do a couple more of these, and then we're going to see how they get to filter, map, reduce. Okay, that's what those are the three biggies in this. Those are the three really important higher order functions. Okay, all right, so, remember, you'll have a homework assignment that's playing around with this stuff. Your homework assignment is going to be very much like what I'm doing here. This will be part of your homework assignment. Examples like these. Okay, so look for that. I hope it'll be up there today or tomorrow. And then next week we'll do more playing around with higher order functions and reading these things as carefully as possible. And don't ask like today, ask about these. There is a lot of information in those little lines of code. This is not baby code. There's a lot packed into these. So ask about them. Make sure you really understand them because this is not boilerplate. This is a lot of information packed in one line of code. It's not easy, but it's meant to be challenging. It's useful. It's not easy, but it really is useful. Okay, so we'll quit there. But if you have questions about it, please ask. All right, so have a nice weekend. Bye-bye.